Okay, so what we're going to do now is we are going to find the forces. Okay, so we are going to again view. We are going to view what we have drawn. Okay, so we're going to view this view. Okay, so we're going to view here. Okay, we're going to take this view. And we're going to take this view. Right, I'm going to get rid of all the moments down here. Okay, so we know that EY, we found EY, right? At gear E is 3730. Okay, so we know that this is 3730. Okay, so I'm going to take the distance so we can see the distance. Right, so you can see the distance. So we are going to find, use static analysis, find. Okay, so we're going to apply static analysis to find AY and BY. Okay, we're going to find. So you ask me why is this necessary? Because we have to find the moments. Okay, so we are going to mention about moment in the Z direction. Okay, because this is we're bringing in XY direction, so this is rotation about Z. Okay, so moment in the Z direction is equal to 0. Okay, we are going to take moment at point A. I do apologize. So we know that from A to E is 0.6 meters. And it's going to counterclockwise, clockwise direction, so minus by 3730. Then plus by 0.8 multiplied by BY. This thing is equal to 0. So BY will be equal to 3730 multiplied by 0.6 divided by 0.8 is equal to 2797 or 2798. Okay, 2798 Newton. Then you do summation about forces in the y direction. So this will be equal to AY minus by 3730 plus by 2798. The whole thing will be equal to 0. So AY will be equal to 3730 minus by 2798 is 932 Newton. Okay. Right. So next we have to find our forces in the Z direction. Okay, so we have analyzed this earlier. So I'm going to copy, right? So this is what I'm going to copy. Right. So we know our CZ and DZ. Okay, so I'm going to, sorry for flipping around, but CZ is 6632, DZ is 2486, 6632, 6632. And DZ is 2486. 2486. Okay, then I'm going to copy that diagram again so you know where we're looking at. Right. So I'm going to take moment. So we can ignore point E. I'm going to erase it. Don't confuse you. Okay. So we can do summation. So we are going to take moment in the Y direction. Okay. So summation about moment in the Y direction at point A is equal to 0. So 6632 multiplied by 0.2 is going to be positive. Plus by 0.42486 and minus 0.8 multiplied by BZ. Then the whole thing is equal to 0. So BZ will be equal to 0.2 times by 6632 plus 0.4 times 2486 divided by 0.8 is equal to 2901. Okay, let me do it again. 0.2 times by 6632 plus 0.4 times 2486 divided by 0.8, 2901 Newton. Okay. Then we're going to do summation about forces in the Z direction. Okay, I'm calling up positive. Okay, does not matter. I know Z positive should be coming down, but I'm just calling up. If it's the wrong direction, you just flip it around. Okay. So you have minus AZ plus by 6632 plus by 2486 minus by 2901. Okay. So AZ is equal to 6632 plus by 2486 minus 2901 is equal to 6217. Okay. And it's in the right direction. All of them are coming down. Okay. So we know that this is 2901. And we know that this is 6217. Okay. So now if I were to draw just focus on the shaft. Okay. So this is my X, Y, and Z, right? So this is our shaft. So point A, point C, point D, point E, and this is our point B, right? So we know at point B we have AZ. Okay, so we have AZ coming down this way. So this is your 2901, and then your sorry, that is your BZ. Your AZ is 62. What do you say? 6217. Okay, so you have a force coming down out here. 6217. Let me see. 6632 plus 2486 minus 2901. 6217. Okay. And then you have your E, right? Your EY. We did know our EY, right? So EY is equal to 3730. So we also know our AY and our BY, right? So AY is equal to 932. So this is 932 and this one is 27. I can't remember now. 2798. And then we have forces that are pulling in this way. Okay. So that we calculate. So everything is in Newton. 6217. So CZ, which we calculate earlier. So CZ is 6632 Newton, and our DZ, okay, our DZ is 2486. Okay, so all our forces are here, and now we can calculate our moment. Okay, we can calculate. So we can calculate our moment. So we are going to do moment in the Z direction first. Okay, so we're going to draw bending moment diagrams. Basically we're going to construct bending moment diagram. Okay, so we are going to focus on MZ now. Okay, so let me copy this thing. Okay, so we are going to focus on MZ. Okay, so I'm going to draw our axis. So this is MZ. Okay, so this is just a sketch. Okay, so this is point A, point C, point D, point E, and then we come back to point B. Okay, so moment of MZ is equal to, so the first point is equal to 0.2 times by 932. Okay, so it's 186.4. Okay, so over here, this is your first point. I'll write down. Okay, so this is 932 multiplied by 0.2. So our first point is 186.4. Okay, so this is 186. And then at point D, still using the 932, right? Because the 932 is causing the moment in the Z direction. Moment in the Z direction. So if you ask me, Eugene, what is the moment in Z direction? This is the moment in the Z direction. Okay. So at point D is, that's why you can ignore the 6217, 6632, 2486. You need to consider 932, 3730, and 2798. Okay. So at point D is going to generate 932 times by 0.4 is equal to 37.8. Okay, so 372. So this is 186, 372. So this is 932 multiplied by 0.4. Okay, and then this is equal to 932 minus 0.4, 372.8. Now these numbers are important. Okay. Then at point E, right, at point E, you can still use 932 multiplied by 0.6, which is 559. So 1, 2, 3, 4, 5, 5, 5. So this will be 932 multiplied by 0.6 is equal to 932 multiplied by 6 equal to 559.2. Okay, so this is 559.2. Right, or sorry, 559.2. Or you can also use 2798 multiply by 0.2, right? 2798, 559